So this is the result I want to achieve for this part. Actually, I know it's not really impressive, but because it's the main structure of the effect, I think it's important to understand it. So let's do it. So let's go with the head setup. So tab geo, if it works, tab geo. Okay, head setup. Good, green, not blue, but green. Okay, let's dive inside. I would like to start with a grid before doing it over the head. I think it will be easier to understand, even though it's not really complicated, but I need a facet. Okay, with a unit point to split every primitive, and let's check this with an exploded view. Okay, up, 0.let's say 8. Yes, that's good. I want to create a primitive, not a primitive attribute, but an attribute called myPrim that is storing every primitive number for each point. So it means, for example, for the point 90, I want the primitive number 72. So there is a function for that called point prim, sorry, and myPrim. This is an array. It returns an array, so I have to get the bracket. Points prim with an s 0 at pitchinum. Good. And I want to store just the first index. myPrim equal myPrims bracket 0, the first index. So I should have for the point 90 the primitive number 72. Let's check that. The point 99, no, 90, 72. So that's good. Let's rename it, add myPrim attribute, and I want a color, red color for that. After this, I want to add the barycenter. So what is the barycenter? Basically, this is the center of each primitive. So for example, if I go there and I type @p equal prim 0 p and at primnum p primnum, this is what I have. So you can see every points go to the their primitive center. So there, but this is not exactly what I want. I want to store an attribute called barycenter. Good. And let's rename add barycenter. Perfect. And a red color. So now I will just want to keep 1 point of each primitive. And in order to do that, there is a function called prim point this time. So int my points, let's say, with the bracket because it returns an array as well. Prim points 0 at primnum this time, like this. And if I will explain it just after. If at pitchinum is different than my points 0, so the first index, I will want to remove the point. Okay, 0 at pitchinum. So basically what it's doing is for each point, this function, the prim points, return an array with the point number 91, 131, 133 and 90. And I'm saying if the point number is different than the first one, then delete all the points. So it means I just want to keep 1 point over each primitive. And this is what it's doing. So 81 points for 81 primitive. So this is good. Keep only barycenter, let's say. Good. Let's have a red color. I want to delete the primitive, so with an add. That's good. And I want to set the position. No. The position now to the barycenter at p equal v at barycenter. Perfect. Okay, so as you can see, it moves to the barycenter. So set v to barycenter. Great. And the red color, Now I would like to have the same sort point than the primitive point. What does it mean? For example, here I do have for the primitive number 0, 1, 2, 3, and I want the same thing for the primitive center here. Oh, there is something weird. Yes, there is. What is weird? P at pin, keep only points, set P, set Barry, center. Is it correct? Yes, it's correct because of the exploded view. Okay. So I want the same thing for this point, and then I have to get a sort by attribute and with my prim. So now I do have 0, 1, 2, 3. That's good. This is what I want. Now I can move the primitive from, oops, not that one, from the particles. So let's do that. This one, look, like this. And I want to import the position of the particles, so the second one. I want to import the primitive position of the primitive for the first input, for the first input, so the barycenter basically. But I'm iterating over the points, so I need an attribute with the petitum to make it match. So let's get the bind with my prim attribute. This is an integer, and I will do it there. Okay, so now I can subtract both positions, like this and like this, and add the difference to the no2, add the difference to the point position. Okay, what? Add. Sorry for that. And like this. And this is not what I should have, so first input, this is good. Okay, perfect. This is not doing anything because I didn't apply any transformation. So let's do that and let's check. Yes, this is good. So this is my points, and it's moving all the primitive together. So now let's apply a noise for the fun. Okay, like this. Turbulent noise with the position. No2. Add. Okay. To the position. Let's set 3D and simplex noise. Up. Okay, so this is what I want. That's good. And let's create the input. So viewX create input parameter, and I would like to apply for the fun the multiply to the time to get an animation. This is what I want. And maybe get the vector component from the position for the x-axis, fit the data from -5 to 5, and multiply the result by the amplitude. So I'm getting this. This is nice. I mean, you can see here there is nothing applied, so that's good. I mean, almost nothing. And now we can remesh everything. So let's rename that before, and I'm using to set the yellow color for the attribute VOP. And now I can remesh everything like this. Okay, let's delete this one. And this is how I've done the head effect, almost actually. So let's get that like this. And that's why as well I haven't done the remesh there, because I wanted to get it inside the setup directly to get more control for the resolution. So I can decrease it if I want to make it more detailed, like this, you know, and then you can play with the noise and add a lot of different operation there. So that's cool. Let's rename this one. Move prim from not from particles. Good. And I used to make like this. Stuck. Good. So let's apply these those operations directly to the head.